Good day, everyone. Now it's time to discuss the second scenario. And if you are not familiar with the kind of series that we have started based on different scenarios related to federated machine learning, I highly recommend you to look at the first video where I have given more details. Together with that, I have also explained the first scenario where the main idea was that together with your federated machine learning model, it is also very important to provide infrastructure or setup related details. And without that, often it is very difficult to continue constructive discussions. And today's scenario is based on cross-device environment. What is cross-device environment? It is basically, when it comes to the federated machine learning, we have two type of use cases: cross-silo and cross-device. Cross-silo is when you have clients with quite a lot of computational and storage resources, and there is a possibility that you can build quite complicated federated machine learning models. For example, when it comes to 2 or 3 hospitals collaborating with each other and preparing this federated machine learning model, or different organizations or different departments within the organization. Cross device is a different kind of setup where the clients are based on the devices, and the devices has limited compute storage capacity. Together with that, the model that you prepare on these kind of environment is not very complicated. But in the end of the day, there are very many number of clients or the devices that joins together and prepare the federated machine learning model. For example, the next word prediction kind of models that we prepared using mobile devices, or health related federated machine learning models where different gadgets are used to measure different readings, and then you use federated machine learning to train your model. Okay, now let's go and look at the more details related to the first scenario. Consider me as a data scientist, a researcher, or a master or PhD student working in the lab or an organization where there is a new project that is about to start, and that is about federated machine learning based on cross-device kind of environment. Everyone is very excited. We have our first meeting where everyone would like to discuss different scenarios, different kind of challenges. And yes, since we previously have some experience with federated machine learning, I also would like to participate in that project. Though I'm not very familiar with the cross-device kind of challenges, but in the end of the day, how hard it could be, I can deal with that. So when we started to discuss things, and boss asked like, okay, who would like to take the lead? I raised my hand and I would like to get started. And in the meeting, there were so many interesting ideas that were discussed. Okay, we have devices, or we need to create an environment, the first experimental environment based on where we have constrained resources. Maybe some clients cannot participate because of the limited amount of resources. Some clients have better resources, this kind of heterogeneous environment, and all these kind of things that are extremely interesting. But at the same time, now I started to feel like, okay, how if I would like to set up this kind of experimental environment, how should I do that? And there is another reality, or there is another, you can say, limitation that I started to think that, okay, what kind of resources will be required for that? Because on my desk, I have only one laptop available. How much I can do with my one laptop based on this whole interesting scenarios that we are discussing, like constrained devices, limited resources, small models, medium models. Some clients can contribute, some cannot, and how you handle all these heterogeneity in the system. So that's the kind of scenario that we have. Okay, now it's time to set up my experiment. And as you know that when it comes to the federated machine learning, there are always two components. One is the server side, and then we have the clients. And server has the responsibility to do the aggregation. And since in my scenario, I have only one laptop with me, I don't want to consume any unnecessary computational overhead on my single laptop. So I would like to go with a kind of framework that allows me to run my server side somewhere else than on my single laptop, because most of the available frameworks that really requires all-in-one kind of setup, where you need to run if you have a single machine, then you need to run server and the clients both on the same machine. But when it comes to the FEDN Studio, we have provided a public SaaS where the server side can be offloaded to the cloud environment in our public platform, and then you can use all your local resources based on your client settings. So here you can see that this is the FEDn Studio interface. I'm logged in as Salman, and these are the 4 projects that I have. We will use this cross-revise project today for the experiment. And as I have mentioned last time, that I will not go into the basic details of federated machine learning. I assume that you have basic understanding how the training process works, and we will only focus on the kind of scenario that I have created. Okay, let's go to the project, and here you can see that different services are available. And what I have done in this project is that I have already completed a couple of sessions, and as you know that in FEDn settings, session is basically the collection of different rounds. And based on those different sessions that I have already completed, I will give you more details about the experiment. So let's go into the session and see. So these are the 7 sessions that I have already completed. Let's go to the first session and see what we can achieve in a very basic minimalistic kind of settings. So if I click on the session view, you can see that in this session, I have 2 clients. I have managed to connect 2 clients to the system, and I have prepared 3 global models. Very nice. And here you can see the 2 clients that I have connected based on my single machine. But there is something missing, or something incomplete in this whole process. So initially I have started with the heterogeneous kind of environment and the settings that allows me to simulate or work with the cross-device settings. But here what you can see that I have 2 clients. Both are using almost the same average training time. So I really don't have that kind of heterogeneous setup, because I'm running 2 clients on my single machine, and both are running almost the same kind of execution time. How do I simulate this kind of constrained environment where different clients have different computational power and can give me more information about the constraints on the client side? For that, I think it's not that difficult, because what you can do is that there are different operating system level commands available, and also there are softwares available like Docker that allows you to restrict resources towards the client process. So after the first session, where I have used 2 clients and both have equal amount of resources, I started my second session where I restrict the amount of resources to the client side. And if I click here, you can see a different plot. So here you can see that the client 1 finished the training process very quickly compared to the client number 2. And here I'm using systemd-run command on client number 2 to just have limited amount of CPU, memory, and storage access. So this actually allows me to build my more heterogeneous kind of environment based on constraint on the client side. So if I can run 2 clients with these settings on my laptop, can I increase the number of clients on my machine? So that's the next step that I have completed, and that is in session 3. So here you can see I have started 4 clients where client number 1 complete the training process based on exactly the same model in around 5.5 seconds, whereas the client number 2 took 50 seconds. And then I tried to test the limits and started 8 clients on my single local machine. And here you can see that if I click on let's say session number 4, I have 8 clients taking different amount of time to train the same model with almost the same kind of hyperparameters provided to the training process. So with this, you can see that, okay, there is quite a lot of information that FEDn Studio can provide you. So these are the client-related information. Here you can see how much time is required to complete each individual round. And together with that, as I mentioned last time, there is a lot of information available that helps you to better understand the model training process. Okay, so now what I will do quickly is to run one session here to showcase like how dynamic information or the live updates can help you to better understand the constrained environment that we have built. But before that, I would like to also highlight the number of running clients that we have. So here you can see we have 8 clients connected to the system, and these are basically something that so these are the 8 clients basically running on my machine, and on this view, you can see that on the server side as well. So let's go and start another session. So new session, I can write ID number 8. I would like to run 3 rounds in this session, and since I have put constraints on the utilization of CPU and memory, I cannot expect a very short round time for this project, because as you know that in FEDn Studio, round time means that how long the server should wait for the clients to contribute. When you have constrained environment, you need to increase the round time so that all the clients can contribute. So let's say we can put that to 250 seconds, and I can start the training round. Let's go and see what is happening in this session. So right now you can see that no clients has contributed yet, and there is no information about the training. So let's wait for a few seconds and see how things look like. And now we can see that, okay, client number 1 has responded, and client number 1 prepared its local model within around 11 seconds. And we will wait for few more seconds to see if the other client started to respond. So with this kind of settings, you can also see that in case some clients couldn't manage to finish the training within the due round time, then you know that, okay, what kind of constraints are too strict and the clients couldn't manage to respond to that. So, and now you can see that 4 clients have already responded. Client 1 took 11 seconds, around 11 seconds, and the client 2 is the one that took almost 53 seconds. So with the same kind of model training process that is running on different clients, having different kind of computational and storage resources, this is the kind of view that you can have in terms of live updates. So these informations are very useful, and together with that, I would also like to highlight that FEDn Studio allows you to work in a more collaborative manner. Your colleagues can also create their account, and you can add them in your project, and then you all can run your setup in a more collaborative manner. They can have access to all this information, you can have access to this information, and there will be more options available in terms of better understanding the overall environment. So now you can see that, okay, the client 6 is the one that took more than 100 seconds, and now I think all 8 clients, let me get 1, 2, 3, 4, 5, 6, 7, 8. Yes, all clients have reported, and we can see that the round number 22 has completed and the round number 23 has started. So this is all what I would like to highlight. Just based on my one single laptop, together with FEDn Studio, I can simulate a cross-device kind of environment where I can train my model. I can report back to my team that how things look like, what kind of models we can prepare, what kind of resources will be required to train that kind of model, and all these things that I can, I would like to report back is readily available through this platform. And yeah, it's very convenient to use in things in this manner. So if you have any questions or anything that you want me to explain further, feel free to contact me or Scaleout team. And also, if you have some scenarios that you want me to prepare some more videos, I will be happy to hear that. Please share your ideas or comments, and we will continue the discussion. Thank you very much for listening. Bye for now.